Hey guys, welcome to lesson 4, scientific notation. We're going to learn how to read and write numbers in scientific notation. We'll be practicing on page 11 and 12, and the practice packet work will be 10 and 11. All right, let's get started. Open up your your note packet to page 11. Let me expand this, and you'll see scientific notation there on the top. Let's begin. What is scientific notation? Well, it's a method for expressing very large like numbers about measuring the universe to very small numbers, like the size of an atom. An example is the number of gas atoms in 22.4 liters, so it's 6.022, which doesn't look very big. But then if we multiply that by 10, it's a little bigger. But then what if we multiply it by an exponent? Well, I should say multiply by 10 23 times. That's much larger. And this number has a special meaning in chemistry. It's the value of 1 mole of substance. Just like it's a pain in the butt for chicken farmers to sell things by eggs, by individual egg, we use a group called a dozen. In chemistry, it's a pain to talk about atoms. There are so many of them in a space that we use moles to talk about how many atoms or any particles, number of particles in a substance. So this is an example of scientific notation. So if we were going to write 1 million, you'll notice there's 6 zeros here, and you'll notice in scientific notation there's 6 there as the exponent. We always move the decimal place to make the number the number out in front between 1 and 10. So this number has a special name. It's called mantissa. Great name for a band. And it's the number out in front. So this is the mantissa right here. All right. I'll emphasize that if I can. I'm still getting used to it, but I think I'm better today than I was in the past. There's the mantissa. Forgive me if I ever mispronounce things. It's the number. It has to be between the number 1 and 9. So it can't be 0.9 and it can't be 10.0. It can be 9.99 or 1.001. So it's a number between 1 and 9. We arrange the exponent. The number to the right, top right of the 10. And then once you do that, you've done all of these steps, you should check your work. All right, and I'll show you how to do that. It's more of a way of thinking, but there is a mathematical way to check it too. All right, but check your work is always a nice final step. Okay, so if you were to take 1 and move the decimal place to 6 places, you would get the number 1 million. So for example, you have this huge number, what would be in scientific notation? Well, the first thing is you find the first 2 digits that give you a number between 1 and 9. And in this case, it would be 1.23. Now, we recognize those zeros there, but we also know that with scientific notation, it's always a power of 10. So I write times 10 to the something. Now that exponent is the number of places you move over. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 jumps that I made. And so this is 1.23 times 10 to the 11th. Hope that makes sense. Okay, and I want you to practice these on your own. So you can pause the video, go ahead and try these, and then check, unpause the video, and you'll see I'll give you the answers. All right, go ahead and try these on your own. Thanks, and see you in a bit. All right, welcome back. The answer is 3.4 times 10 to this is 7 decimal places. This is 6.7. Now you'll notice the decimal moves another direction. And it moves 6 places. But it started off as a very small number. That's something you want to recognize the difference. This is a very large number. And you'll notice positive numbers for exponents correspond to large numbers. Small numbers have negative exponent. So I'm going to still write it as a power of 10, but in this case it moved over 6 places and it started off as a very small number. This indicates a very small number. Okay, so this one is just the old standard 2.5864. That's a number between 1 and 9. And how many places did you move it over? To 4 places. All right, translate back again. If you haven't already done these, try these. And well, I should have put a dot there. First, you write out the number in its entirety. And then now you've added enough. What I did was I added 8 decimal places I popped over. So I went 1, 2, 3, 4, 5, 6, 7, 8. And that's where the new decimal point is. Now, leaving all these jumps makes it a little messy. So if you have done that, that's not a problem your first few times. But try to leave it out. And then I put commas, through every section of powers of 10 with 3 sections of power of 10. And that gives us 570 million. All right, how about this one? A very small number, right? It's actually a little bit of a challenge to write. But I'll tell you, I'm going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. And you might go, why not 11? Well, the 11th one is jumping to the 6. So 6, 3, 4. And that, that is the answer to those. Okay, how about calculator practice? Well, first, let's try to enter the calculator. 2.3 times 10 to the negative 5, type 2, type the decimal point, type 3, you got 2.3, no problem, right? Then you usually will see an exponent button or a caret button, and that caret button is used to signify everything afterward as an exponent. And then plus the plus or minus, I shouldn't say plus or minus, positive or negative key, not the minus key, the positive or negative key, and then type 5. And that will get you the number, and that's easy as that. All right, what did you get for your number? Write your answer here. All right. Measurements and the metric system. All right, so many of you know that we use the metric system here in the United States and around the world, but we also use a standard measure system, the English units. So we use both, and we sort of have to be good at both if you're going to be in sciences, so in chemistry or in economics or business. In chemistry, we measure using what we call SI units, International Standard. This is an abbreviation for System International. I think it's French. So to me, it's weird to write it as English, but there we go. System International. That makes more sense in French, I guess. Is base units. So base units. If you forget to use table D, use your reference table. So I don't know. I was going to say if you should have your reference table, but if you don't, get it out now. The reference table D, you'll see meters and all the different measurements and how they use them. The new ones are the ones I like you to pay attention to. I don't like you writing all over your reference table. I like to use it. But at least we have this copy in your notes you can write. So that's important. What I was going to emphasize if I could, but I seem to have trouble with. No, I can't seem to do it. Sorry about that. What I was trying to do is emphasize that there's units on here you might not have seen. So meters, parts per million. I think you've heard of seconds and liters, but you might not have heard of joules. We just talked about moles. You might not have heard of Kelvin. It's a way to measure temperature. And pascals are probably new. So each time you see something that you recognize that, but recognize there's also new things in here. Okay, selected prefixes. Some of these you might know, some of these you might not. Someone says K in front of a unit, you know there's 1,000 of that unit. If they use centi, you know there's 100th of that unit. And micro, nano, and pico are all measurements that I think are new to people as well. All right, this is a way to like what you multiply by. So when you say you have a megawatt of power, it means you have 1 million watts of power. All right. And I think that's it. You're going to go into the practice packet now. And let me just close that off. And there we go. And go to page, let's see, what page did I say? 10 and 11. Let's take a look at your homeworks and make sure, oh, wait here. Perfect. And this will be your homework tonight. It's nothing that you'd be surprised by, I think. You're just going to be doing expressing things in standard form and then moving from standard form to scientific notation. I think they start off pretty easy. I'll do one with you. Like this one is hard because it has a negative exponent. Remember, that means it's smaller, so the number will get smaller. And the way I do it is I start here and I move it over how many places? 4 places. But that first jump will just bring the 9 up front. So I start like this. There, 0.0. The first jump is 0, and I write 3 zeros. But I know it's -4. But that's my next number will be the 9, and then the 6, and then the 5. And if you work backwards, this is the checking work part, you'll notice that, oh, if I move backwards, I go 1, 2, 3, 4. You notice how I get a number between 1 and 9, just like we talked about. Check and check. All right, these I think are pretty easy. I've talked about those. Convert all the scientific notation and vice versa. Same but mixed practice. There's something tricky here. I don't know what it is. It's the same idea. It's just giving you practice converting back and forth. All right, that's it for today's notes. Good luck. Thanks for